Hey everyone, today we have the second page of the 8.3 notes. You should be watching this on Wednesday, April 15th. Yesterday we did the front page of the 8.3 notes. And that was just kind of talking about the letter E in general. I said, hey, there's this weird number that has some applications that we can sometimes use in this class, but a lot of the applications are used outside of this class. We talked about the difference between evaluate and simplify. Again, evaluate, we wanted our final answer to be a number. So we used 2.718 for E, that's the value of E. When the directions said simplify, we just treated E like it was a variable, like it was X. So today we're going to talk about some of the applications of E. One of them is graphing exponential functions. So the first thing you need to know is the base formula for the natural base exponential function, which is y equals a times e to the r times x minus h power plus k. Now that looks very, very confusing, but a few things you got to keep in mind is, first of all, e is a number. That's 2.718. It's not really a letter because it's not a variable. We know the value of that e. The other thing you need to keep in mind is that hk, we've dealt with that before. That's just the starting point. Like, for example, if we had a parabola that was in the form y equals, oh boy, in the form y equals x minus 2 squared plus 3. Again, that's just in the form y equals x minus h squared plus k. So you've seen the h and the k before. The only thing that really changes are the r and the a. Now, we're not going to get into this much. So I am actually going to cross this section off. All I really care about right now is graphing them, and I'm going to explain why. With this whole shutdown and the quarantine and everything, the Algebra 2 teachers kind of talked, what are some things that they need to know and what are some things we can kind of kick out? This portion is something we're going to kind of kick out. I am, however, going to focus just on these two graphing problems. Now, the nice thing about this is, hey, let's just use a calculator. The bad part is a lot of us don't have good calculators to work with. So everything I'm going to do is going to be based off of using the Google calculator. So just type in at google.com, type in calculator, and this kind of computer screen calculator should pop up. Okay, now right when that pops up, right in the search bar, you can just type in each equation. So first of all, we got to figure out some x values to plug in. What's the easiest value to always plug in? 0, 1, 2, and then we should also go negative. So we can go -1, -2. And it doesn't really matter if you ended up putting -2, -1. Mandy, shut up. Sorry, people. I'm going to go close my window just a second. All right, sorry about that. So it doesn't, like I was saying, it doesn't matter if you put the letters in blue or in black. Like what order you put them in is not necessarily important. I usually just start with 0 because it's, for me, that's the easiest number to plug in. So the first thing we should do is say, okay, we need to put this in using the order of operations. So when you plug 0 in to this equation, it would be -2 times e to the 0.5 times 0 power. And a lot of this you can do in your head. Sorry, I had to flip on a light. Okay. So this is the portion I expect you to be able to do in your head. You should be able to say, okay, well, 0.5 times 0, that's 0. Any number times 0 is 0. Now we have -2 times e to the 0 power. Well, now you should know e is a number, and any number raised to the 0 power is 1. So now it's -2 times 1. Hey, well, that's just -2. 0, -2 is your first point. Okay, now what I'm going to do is I am just going to put in values right here. So I'm going to erase everything. I'm going to erase all of this and just plug in a new value for that highlighted yellow portion. Come on, buddy. You can erase. Come on. Boom. So the next value I want to plug in is 1. So now what's 0.5 times 1? That's just going to be 0.5. So I have negative 2 times e to the 0.5 power. And again, what we can do is just type that into Google. Negative 2 times, to get times, shift 8. Negative 2 times e raised to the 0.5 power. I hope you're typing that in along with me. You should kind of be like following along, so to speak, with me if you can. Okay, so now when you type that in, it should look like this. Negative 2 times, that's a little asterisk, e raised to the 0.5 power. When you type all it in, hit enter, you should get negative 3 point about 3. I'm just going to go to 1 decimal here just because it's not that much space. And when I look at this graph, I'm not going to be able to tell the difference between negative 3.3 and negative 3.297442514. So you can just round to 1 decimal for now. Go. I did not mean to do that. Okay, and again, now the only thing I'm going to change is this number that I plug in for the red 1. I'm going to keep everything else the same in my base formula. All that I'm changing is the x value that I just highlighted. So that's all I'm going to change out here. Now instead of 1, I have 2. And again, this first step you can do in your head. Negative 2 times e. What's 0.5 times 2? Well, you should get e to the first. Now just type in on Google negative 2 times e to the first power. You should get negative 5.4. Easy peasy. Now we're going to do the same thing for negative 1. So again, everything else is going to get erased besides the number I'm plugging in. Now I'm plugging in I am going to plug in a negative 1. The first step you can do in your head. Negative 2 times e, negative 1 times 0.5 is negative 0.5. Okay, when you type all that into your calculator, negative 2 times e caret negative 0.5, you should get negative 1.2. Okay, last but not least, the only thing that changes is this number is no longer a negative 1. It's now a negative 2. If I were you, I would pause the video right now and try to plug this in on your own because you should get some practice doing it. Okay, now after you've hopefully resumed, I understand not everyone's going to do that. That hurts my feelings, but hey, what are you going to do? Okay, but now when you do negative 2 times 0.5, the only thing that changes here is this turns to a negative 1. Okay, negative 2 times e to the negative 1 power, you should get negative 0.7. Okay, now we just need to graph this. I'm going to erase these numbers on the side just so that no one's confused anymore. Okay, x is 0, y is negative 2, 0, negative 2, boom. 0, negative 2, hopefully it actually goes this time. 0, negative 2 is right there, over 0, down 2. 1, negative 3.3, right 1, down 1, 2, 3.3. Over 2, down 5.4, 1, 2, 3, 4, 5, and it just goes a little bit off. Again, you don't have to be perfect because I can't tell the difference between negative 5.4 and negative 5.6 really on this graph. It's hard to tell. Just be as close as you can, eyeball it. Okay, next up we have negative 1, negative 1.2, so that's left 1, down 1.2. Last but not least, negative 2, left 2, down 0.7, so about right there. Now, one thing you need to see is that this is not linear, and what I mean by that is if I just connected these points right here, my line would look something like that, right? But as you can see, these 2 points right here don't fit on my line. That's because my function is exponential and it should be curved. So my graph is going to end up looking something like this. It's not going to be perfect, but it's going to go something like that. And it's very hard to graph using the iPad and the pencil, so my apologies, but you should be able to see that curve there. So now we just got to figure out what our asymptote, domain, and range are. Now, if you remember, an asymptote is something that it gets really, 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 really close to but doesn't touch. In other words, what's going to happen is this red line is going to get infinite, that shouldn't have been red. That red line is going to get infinitely close to this yellow line. So the further I go over, this thing's going to get really, really, really close, but it's never going to actually touch that. Hope you remember that from when we were still in session. But now, that's a horizontal line. My yellow line is horizontal. So that should be a hoi, so it's y equals something. And where is that line? It's at y equals 0. Why does that help us? Well, my range is going to be the exact same letter and exact same number. So my range is y and 0. The only thing that changes is my sign. So now we got to ask ourselves, okay, well, is my graph above this line or below my yellow line? You should say, well, it's below, duh. So if you're below the line, that's going to be a y is less than 0. For the domain, remember, domain is the possible set of x values. So on the x-axis, it goes forever this way. It goes forever to the left. It also goes forever to the right. So my domain is just all real numbers. So again, domain is a set of x values. Range is a set of y values. Let's go farther into this range. I just want to talk about this for about another 30 seconds. For the y values, that's why it's a y equation. Y is up and down, right? So what's the highest it goes on the y-axis? What's the highest it goes on the green line? Well, it's going to get really, really, really close to the yellow line, which is at y equals 0. So it's always going to be y is less than 0. That's it. We made an XY chart. We plugged in our points. We found the asymptote, the domain, the range. Again, how you do this? All you need to do is plug in your values. Okay, last one for today. We're doing the exact same thing. Let's plug in some easy numbers. Okay, this time I'm going to go in kind of order: -2, -1, 0, 1, 2. The first thing you should ask yourself is, what's always an easy one to plug in? 0. So let's start at 0. Okay, so we're going to have y equals, I'm on the highlighter, I should get off that. Y equals e times 0.4 raised to the 0 plus 1 minus 2. Okay, again, some of it you can do in your head. What's 0 plus 1? That's 1. What's 1 times 0.4? E to the 0.4 power. You should be able to do that in your head. Minus 2. Let's just type that into Google again. E caret. The caret is shift 6. I don't think I ever said that. I should have said that before. E caret 0.4 power minus 2. You should get negative 0.5081. So let's just call that, let's just call that, it's the first time that's happened. That's kind of impressive. Let's call that negative 0.5. Negative 0.5. Okay, again, all that I want to change is the x value. So all that's going to change here is my x value, and all of this will also end up changing. Okay, so I'm going to erase this. I'm going to plug in my next x value. My next x value, let's go negative this time. So let's plug in. Oh, did I do that wrong? Shoot. No, I didn't. I'm okay. I just wrote it wrong here. Plus 1, and I plugged in 0. That's where I was confused. I highlighted the wrong x value. Duh. So guys, what I did wrong is I just highlighted this wrong and this wrong. I didn't really do anything wrong. I highlighted the wrong thing and erased the wrong thing. So now I'm going to plug in for x, the one on the left, and I'm going to erase this. I'm going to plug in negative 1. Negative 1 plus 1. So now negative 1 plus 1 in your head, you should be able to do 0. So this is e raised to the 0.4 times 0 power minus 2. Okay, well, 0.4 times 0 is just 0. E to the 0 minus 2. Well, when we do that, any number to the 0 power is 1. So e to the 0, e is a number. E to the 0 power is 1 minus 2. 1 minus 2, you should get negative 1. Okay, that's the easiest one to do because, again, when we get a 0 power, that makes our life much, much, much easier. Okay, Now, the next thing we're going to do is plug in another number. Let's plug in -2 this time. Again, so for my highlighted part, the first one, which I screwed up before, again, I'm plugging in right there. I shouldn't have made it that dark. I am plugging in right there. So what I'm going to erase is my first one, and now I'm going to plug in a -2. Let's plug in -2. So -2 plus 1, we should get y equals e to the 0.4 power times -2 plus 1 is -1 minus 2. Now, 0.4 times -1, we should get e to the -0.4 power minus 2. All we need to do is plug that in to our calculator on Google. E caret -0.4 minus 2. We should get -1.3. Okay, again, I would encourage you to pause the video each time. So the next number we want to plug in is going to be 1. So let's plug in 1. This should be easy as well. Come on. So I'm going to plug in a 1 right here. Should get e to the 0.4 times 1 plus 1 is 2 minus 2. You can do the next step in your head as well. What's 0.4 times 2? Should get e to the 0.8 power minus 2. On your calculator, you're just going to type in e caret 0.8 minus 2. You should end up getting, again, I'll type that in, what you should type in, e caret 0.8 minus 2. E caret 0.8 minus 2. When you type that in, it should be 0.2255. So when you type in 1, you should get 0.2. The next thing, all that's going to change now is, instead of a 1, let's plug in a 2. So the only thing that's going to change is this number. E to the 0.4, what's 2 plus 1? You should be saying, well, 2 plus 1, that is 3. 2 the times 3 minus 2. Now we can do this next step in our head, or you could use the calculator as well. 0.4 times 3, that's the same as 4 times 3, but just put a decimal in between. You should end up getting e to the 1.2 power minus 2. Okay, when you type all that in, again, you're typing in e caret 1.2 minus 2. E caret 1.2 minus 2. We should end up getting 1.3. Okay, now we just got to plot our points. I did not try to do that. Now we just got to plot our points. -2 tells us left 2. -1.3 tells us down 1.3. We're going to end up about right there. -1, -1 means left 1, down 1. 0, -0.5, over 0, down 0.5. Right 1, up 0.2. 2, 1.3 is right 2, up 1.3. Okay, as you can see, the further right we go, the higher up we go. So our graph should look something like this. Now, you should be able to see, hey, this is going to get really, really close to this line. If it gets really, really close to a line but doesn't touch it, that's again called our asymptote. So our asymptote is a horizontal line. So it's a HOI. So it's y equals, and how far down do you go to get to the green point right there? Well, you go down 2, so y equals -2 should be your asymptote. How does that help us? Well, for the range, it's going to be y and -2. Range is a set of y values. That's why we use y. Now, the only thing that changes is the sign. It changes from an equal sign to something else. And you got to ask yourself, well, is my graph below my asymptote? If it's below, it's less than. Or is it above my asymptote? If it's above, it's greater than. Since my purple graph is above the yellow line, that's going to be y is greater than negative 2. And if you remember this from before the shutdown, the range for all of these exponential functions is going to be all real numbers because it goes forever and ever to the left and forever and ever to the right. Okay, that is all I have for you today. Again, I'll post a few problems on Google Classroom. These are going to be a little different. I believe I'm going to write out just three problems, and your job is to graph them. Again, please submit them via Google Classroom and not via email. It makes my life a ton easier, and if you need directions on that, I'm still happy to help you. Yeah, hope you have a great day, and I will talk to you tomorrow.